Hello, my name is James Helfrich. I'm here to present the paper Artificial Intelligence Maturity Model, otherwise known as AIMM. There is a large demand for more effective use of AI resources. Though a large number of technologies, best practices, and techniques have been developed, the degree of sophistication of AI use remains low. There is an urgent demand to encourage practitioners to better use AI resources. Maturity models such as CMMI have proven useful tools to help both practitioners assess the sophistication of their practices as well as provide benchmarks they can aspire to. There is, as of yet, no maturity model characterizing the use of AI. Our research question is this: how can the sophistication of an individual's use of AI resources best be characterized? A literature review was conducted to discover the types of AI utilization. 14 distinct techniques were discovered. A qualitative study was conducted where 27 individuals were interviewed, totaling 497 minutes. Each interview was coded according to the techniques employed. The data was correlated with the theoretical framework discovered from the literature review, and the resulting analysis informed AIMM, a four-level model. The literature review revealed three main lines of inquiry. The first is prompt engineer. The most frequently cited techniques under prompt engineer include chain of thought, chain of symbol, automatic chain of thought, least to most, self-consistency, and tree of thought. But of these, there are a few common themes, and those are familiarity with large language model technologies, providing adequate context, providing specificity, and providing hints. The second category in literature review is iterative prompting, and the most frequently cited techniques included multi-term prompting, prompt refinement, human in the loop, supervised prompting, rhetorical prompt engineering, prompt optimization with human feedback, prompt optimization in multi-step tasks, and iPro-opt. And the most common characteristics there are redirection, road mapping, delegation, assembly, and evaluation. The final class of papers is AI agents, and the most frequently cited examples of AI agents include Sui Agent, Web Shop, Mind Dojo, but there are literally hundreds of AI agents described in the literature. The common characteristics to many of these are autonomy, reactivity, proactiveness, and they're built to perform a specific task. From the nearly 500 minutes of recorded interviews from 29 different participants, we took the 17 tags derived from literature review and coded the interviews, and that gave us the four-level model of AIMM. The first level is Novice. This is the introductory level where everyone begins. The second level is Prompt Engineer. These are they who understand how the technology works, what it can do, and what it cannot do. They also provide the necessary context to a prompt, and their prompts are characterized with a high degree of specificity. The third level is an agent manager. Agent managers break large tasks into small tasks, each of which is delegated to an AI agent. There are 5 activities common to agent managers: orchestration, delegation, evaluation, redirection, and integration. The fourth level is an agent engineer. These are they who train LLMs to perform tasks they were previously unable to do. Let's dive into each of these independently. Levels 1 is novice. This is the initial level where everyone starts. The main characteristic of a novice is they harbor misconceptions about AI or they have incomplete knowledge. They avoid AI or use it for very narrow purposes, and they often fail to get satisfactory results. Every subject interviewed was at least a novice, of course. A typical novice prompt to proofread a passage of text is this: proofread the following text. Level 2 is a prompt engineer. The literature review highlighted 2 primary characteristics: context and specificity. Context is systematically providing all the necessary background information to perform a task. If the AI agent needs any information before the task, the context is that information. The second is specificity. We are extremely explicit about exactly what is to be done and how is to be done. Prompt engineers are intentional about providing both of these with each prompt. The literature review also identified a collection of secondary techniques often employed: providing hints, explicitly describing the role the AI is to adopt, and providing at least rudimentary examples of what the output should look like. From our study, most who consistently and intentionally provided context or specificity in prompts also provided both. Back to our proofing example, a prompt typical of a prompt engineer would be the following. In this case, simple rule is identified, the context of the paper is identified, and the prompt specifically states how the paper is to be proofed. The third level is an agent manager. These are they who do not expect an answer with just one prompt, but rather manage the solution process through a collection of interactions. There is one defining characteristic of agent managers, those who plan on using multiple interactions with AI to get the response they desire. Additionally, agent managers often explicitly evaluate the quality of subtasks, provide redirection until a given subtask is completed in a satisfactory way, and plan on assembling multiple pieces to represent the final solution. From our study, most agent managers also consistently plan on redirection and assembly. Additionally, they tended to employ almost all the secondary prompt engineering techniques. Back to our proofing example, agent managers would not attempt to perform the entire task in one go. Instead, they would ask AI agents to perform subtasks, one at a time. Each subtask would be carefully evaluated and refined until satisfactory results are achieved. The fourth level is agent engineer. These are they who intentionally train LLMs to perform specific tasks relevant to their workflow. The defining characteristics of agent engineering is two. First is they create a file for the specific purpose of performing a task, one file per task. These files are often very large and detail-oriented. And the second, these files are saved and used again and again and again. Additionally, agent engineers often use sophisticated steps describing how to solve the problem. Their instructions include prompts to obtain missing information. They provide extensive and exhaustive examples of the task being performed. And their descriptions of the role the agent is to assume are often very sophisticated. These instruction files, sometimes called task markdown files, are often several pages long. Agent engineers frequently say their collection of task markdown files are amongst their most valuable intellectual assets. They invest heavily in them so they can perform their best. There are several possible avenues for future research. Correlating the sophistication of AI utilization with the quality of the results, developing novel agent management techniques, designing strategies for optimizing agent training, and exploring teaching methods to help human AI users advance their sophistication in AI use.